This is video number 42. This is my new concept for computer technology for Jane, the system that I'm building. My thought is that the quality of the sword begins with the strength of the metal. So when we build any device of any kind, specifically software, but if we kind of judge that to a sword, we want to look at what do we start with in our current software development baseline. What is it that we start with? We start with operations that we can perform. We can add, subtract, multiply, divide, compare, shift, and move. A few other little ones, but basically this is our world of the materials we have to work with. We have a very limited number of representations, base 2 numbering system with a fixed number of bits, limited set of bits, and this is our world that is our baseline. And then we have individual isolated craftsmanship, which is each application we build is independent from any other application. So it's non-reusable code. So you write a great application with a lot of capabilities, you can't really use that for another purpose. I've tried. It doesn't work. You can say, well, I'll write an API. Well, that really doesn't work, but unless you really have a purpose for it, which generally we don't. A lot of people have tried, but I won't use APIs or libraries or things unless I can absolutely can't do it. And our baseline is a client-server technology, which has no flow control, which are functions. Basically, anytime you send values over to another machine or to another part of your own application, it's this client server. I'm the client. I have these 4 values. I want you to sort them. So you send that over to a function and you get back the result or whatever it is. And this is, to me, is client server. Client server does not work because we have no control of the server. It does what it's going to do. And that's it. And if you make it complex, then you're trying to put in permutations, and that really doesn't work. So if you're writing software and you think it's a sword, you would start every application with only a shovel to dig up some material, to copper, aluminum, or something. You have a match so you can start a fire and somehow forge this into a block and bang it out, and then you have a book. This is how you dig up the material you need. And so we all start, every application is an individual craftsmanship. And we start literally at digging up the dirt, building our logic, and we don't really get anywhere with this. So I want a new software baseline. This is what I want to go to, a new technology. So we want to have absolute control and capabilities in our characters that we represent sound with. Sounds we start with, and then we over the 1,000 years, we've come up with 26 characters that we can represent all of these words or sounds that we want to make. And then that's our communication. And our number representations is quantity. How do we represent different quantities? And we need we need a technology on all of this. Means that there are many, many different ways to represent a quantity. It could be a number, could be an integer, it could be a real number, it could be a clump, imaginary number, it could be a fraction. So we need complete technologies for numbers. And knowledge, we need a complete representation of complete thought. It means that when I think of elephant, I don't think of it all at one time, but I can put the pieces I have together. They're gray, they're big. These are the things that I know when I say elephant. I don't have to go out and search those. Our brain does this somehow, but in our logic, when we build anything, it's basically we group things when we know those things come together. And partitions, this is where it really works. Yes, I grouped those, I did that. And so we need this grouping capabilities of segregating our knowledge base into physical partitions, and if not, logical partitions, meaning kind of like a table. I can read records 1 through 5. Those are generally not partitioned, it's just a selection. In a lot of the cases, we want physical partitions. I only want the blue ones, or I only want the ones from last year. If it's a big group like that, speed is, this is why we do it. We have physical partitions. And we want to build technologies. In this particular, in my Jane technology, it's a technology for everyone, means that we are building technologies for every purpose. So physics has its own requirements for their technologies. And same with mathematics and chemistry and dance and music and transportation and air traffic control and banking, and every technology has that. And we want to build complete solutions, meaning that we want them to be free to move forward and do whatever is required for their particular technology, and not be reliant upon the computer industry to build a better technology. This is really where we're at today. We are waiting for the computer oh, we're going to do AI, and in 20 years that'll really solve it. And we want everything shared, all of our logic and information to be shared. Right now we have no sharing of logic or of information, period. We have billions of applications, but we have no sharing between any of them. Word only works on Word, Excel only works in Excel, and so on, and databases and all the editors and everything else. And graphics is basically one of our visualization tools, but we want visual representations of all of our graphic needs. So every technology out there, physics and chemistry, they want to draw molecules, and physics want to do in-kind planes and trusses and tensors, and all of these things are represented at our visual representations. And these, what I'm saying, are built into the base technology, so that we don't all of our applications do not have to write these. These are done for us. And so what we want is trust. We want to, yes, I trust that application to do what I want it to do today and in 100 years from now. And I want it secure. I want my security on there so that I know I run the bank, I run the post office or whatever. I want to make sure my system is secure above all else and knowledgeable. So I want to know, when I'm looking at a bank record, I want to make sure that it applies to this particular individual, and I need to know the information. When was his last payment, and all this knowledge, and completely accessible, instead of having to ask somebody else in some other department to get me. I've worked in a lot of companies, and I'm sitting there and I see these guys coming to IT department and asking, where does $500,000 go? I'm saying, Jesus Christ, that's nuts. Anyway, and then we want absolute control by the people that own the hardware. This is my hardware. I want absolute control of everything, of every application that's running on it. I want all the source code. I want absolute knowledge. My conclusion is we want to supply every application's need. Piler, the system in itself, has all this logic that is very small. We're not talking about billions of lines of code. We're talking about extremely small. Your work is to determine, how do you fly the plane? How do you get 483 subsystems to communicate? That's my problem. What you do with that communication, I researched flight control systems from NASA, and one of the things I found out that Grumman builds a lot of these subsystems, and they said there's only 483 of them. So you just write it for all of them, and then you put them together. That's all we really have to do. And context, we want everything in context, so that when we're over, Benjamin Franklin's name, we can right click it and say, when did he go to France? Or, we can ask everything in context. And then we make sure that we give complete technologies for just about everything. Numbers, I want fractions, I want mathematics, I want graphics, 2D, 1D, 3D, whatever visualization tools we want, that should be built in. and then the access to every value of every bit that's on every computer in the world. Period. But and that's all done for us. So if we say, look, my wife has contact, give me my wife's phone's contacts, and the system will do that for us. Or this database is across 15 computers. Go get me, find me Bob Smith and bring back his information. And organization. So this whole system is designed to have complete organization, cataloging of every piece of information before we get our first value. That's what we're after. And then that retains forever, so that no one has to worry about where things go, how to find things. That's all built into the system. And we want reduced number of source line codes. This number of code. We should not have billions of lines of code doing very little. We draw lines, text, and images on the screen. For us, we want one line code, draw it. So we really, in reality, pay employees. And our compiler automation of the baseline technology, that's what we want. We want all of our baseline technology to be handled for us, so we don't have to do any of this work. Build me a new compiler and add me a new statement and type, and it deals with inventory. And we're removing the human from the equation is what we're really trying to accomplish. As we get new technologies or have to modify, everything's changing constantly, so this whole system has to be changeable by the end user, so that they're not waiting on our computer technology to give them new capabilities. That is wrong. We should have every technology. So if you're mathematics and you want to come up with a new symbol for something, he should be free to build that technology right there in a couple seconds. Okay, well, that's it for my view of what remove our dependency on the hardware and remove our dependency on the operating system and all of our base technologies that are handled for us provide very little help to us when we write our applications. Well, we take that away from them and we give it to you. All right, until next time, thanks a lot. Have a great one. Bye now.